This is our second video in the antiderivative series, and again we're going to be working with the derivative of a function, a rate, and seeing how that will help us determine information from a problem. So the first one that we're looking at here, it says the total number of DVDs in billions per year sold to U.S. dealers for rental and sale from 2000 to 2003 grew at the rate of approximately d prime of t, we're given that, where t is measured in years with t is equal to 0 corresponding to 2000. The total number of DVDs sold as of 2000 was 0.1 billion. So I want to stop there for a second, and again, this would be a good place for you to pause the video, because what you want to do is anti-differentiate d prime of t, and remember, you're going to have your big plus c at the end. But with the plus c at the end, I've given you some information to determine what that value is. So that should be very straightforward, I think, for part A. So you can pause the video here if you need to. So what I'd like to show you is what I've done with this problem. So the first thing I did was I said, okay, the antiderivative d prime, or d of t, is going to be equal to negative 0.05 t to the third power. I have times 1/3, or you could have divided by 3, plus 0.28 t squared times 1/2, meaning or divided by 2. Really, that does not matter either. And then at the end, we have our 0.038 t. Well, for this one, c must equal 0.1 billion, because we're saying that at 0, we don't have any e's in this, so if all of these t's are 0, then c must be 0.1. So really, the only time you're going to have to go about solving, is if you've got an e or something else in there that would, lead you to believe that the c value is not what's stated at 0. Then all you're going to do is you're going to use that formula and evaluate it at 3. And so you can see what I've clicked on here. There's our antiderivative. And when we evaluate our antiderivative at 3, we get 0.796. And remember, 0.796 is billion CDs. You could convert that if you wanted to, and take 0.796 and multiply it by a billion and see what the number is written out with the zeros. But that's how we would answer that question. Let's move on to the second one. The second one that I have here is the growth rate of revenue for company ABC is R of x is equal to 6x plus x squared if the revenue is $13,500 when x units sold is 2, find the function. The wording's a little bit off there, but I think you get the general idea. So again, the growth rate of revenue. So even though I don't use the prime symbol there, I've said growth rate. So that means I've given you the derivative. The very first thing that you should do is anti-differentiate. I'm hoping that the more I say rate to anti-differentiate is going to help you build this pattern over and over. So we're going to anti-differentiate R of x there, that growth rate, and then we're going to use this information. If the revenue is $13,500 when x units sold is 2, we're going to find the function. So all that information helps us do is find our c value. So again, pause the video here if you'd like. And if you're coming back now, If you look in the text box here, I have my antiderivative, 3x squared, right? Because I would have 6x squared divided by 2, so that would be 3x squared, plus x cubed divided by 3 plus c. But now I really just want to solve for c using x is equal to 2 and r of x is equal to 13,500. So when I do that, I basically end up with the value of c. So here in this box you can see my calculation. I basically set up an equation and solved it, but to be able to use Excel and solve that, it's 13,500 minus the values that we have when we think about our antiderivative being evaluated at 2. So 13,500 minus 6 times x squared or 2 squared divided by 2. That's my 3x squared. Don't get confused with that. And then 2 cubed divided by 3. So with that said, using that calculation, that's how I would get my function for my revenue. So I went from my rate, my growth rate for revenue. I have a value for revenue when 2 are sold. That helps me determine my function.